Greetings to all. Welcome to a new series in which we will discuss VPNs. We'll use all the VPN techniques in this series from PPTP to zero tier. So let's get started. What is VPN? A VPN or virtual private network is a technology that allows you to create a secure connection over the internet. It works by encrypting your internet connection and routing it through a server operated by the VPN provider. This helps to protect your online privacy and security by hiding your IP address and encrypting your internet traffic, making it much harder for third parties to intercept and decipher your data. We are going to look at PPTP. PPTP stands for Point-to-Point Tunneling Protocol. It's a method for implementing virtual private networks, VPN. PPTP allows you to create a secure connection between a remote computer and a private server over the internet. This protocol encapsulates data packets from various protocols such as IP or IPX within PPP, point-to-point protocol, and then encapsulates those PPP packets within IP packets for transmission over the internet. PPTP is widely used due to its simplicity and ease of configuration. However, it's considered less secure compared to other VPN protocols like IPsec or OpenVPN, mainly because its encryption methods are relevantly weaker and can be vulnerable to certain types of attacks. Many organizations have transitioned to more secure VPN protocols, but PPTP is still supported by many systems and devices. PPTP pros and cons. PPTP is easy to set up compared to other VPN protocols, making it a popular choice for beginners or those who need a quick solution. Compatibility. PPTP is supported by a wide range of devices and operating systems, including older systems like Windows XP, which makes it convenient for users with diverse setups. Speed. PPTP offers faster connection speeds compared to some other VPN protocols due to its lower encryption overhead. This can be beneficial for activities like streaming or online gaming where speed is crucial. Security concerns. PPTP is considered to be less secure compared to other VPN protocols like OpenVPN or IPsec. It has known vulnerabilities and has been compromised in the past, making it unsuitable for applications where strong security is paramount. Limited encryption. PPTP uses weak encryption algorithms compared to other protocols, which can make it vulnerable to attacks, especially against determined adversaries. Blocked by some networks. Due to its vulnerabilities and security concerns, PPTP is often blocked by corporate networks and some countries' firewalls. This can limit its usefulness in certain environments where more secure protocols are required or mandated. Unsupported by some platforms. While PPTP is supported by many platforms, there is a growing trend of platforms dropping support for its due security concerns. For example, recent versions of macOS and iOS have removed support for PPTP. PPTP. TCP port 1723. PPTP uses TCP port 1723 for control message. IP protocol 47. While the control connection uses TCP port 1723, the actual traffic in PPTP is carried over generic routing encapsulation packets, which use IP protocol 47. Layer 3. PPTP operates at the network layer 3 of the OSI module. It encapsulates PPP point-to-point protocol frames within IP packets for transmission over an IP-based network. MPPE, Microsoft Point-to-Point Encryption. PPTP supports Microsoft Point-to-Point for encrypting the data traffic between the client and server. Microsoft Point-to-Point provides encryption for the data transmitted over the PPTP channel, enhancing security. Server and client. PPTP involves a client-server architecture where a PPTP server accepts incoming VPN connection from PPTP clients. The server authenticates clients and establishes a secure tunnel for data transmission. Let us now examine our network diagram. Three of our clients in Bloemfontein require VPN connection to the Johannesburg office in order to access the Johannesburg office server for work purposes. We are going to set up a site-to-site PPTP connection right now. They will supply a username and password for the Johannesburg office, but firstly we'd like to show you how to set up the PPTP server. After that, we'll set up the client side for the 3 clients. Click P and then PPTP server. Since PPTP isn't very safe, we'll select to use default encryption and increase the security of the tunnel. Let's set up the client's username and password for the P tunnel in order to authenticate. Local address. The local address is the IP address assigned to the mikrotik router's interface that will handle the PPTP connection. Remote address. The remote address is the IP address that will be assigned to the PPTP client connecting to the router. Our client's PPTP username and passwords are set up, so let's log into the client's mikrotik and configure the PPTP client so they can connect to the office server in Johannesburg. The PPTP tunnel is now working, and mikrotik's updated firmware is simply reminding you that PPTP is unsafe. Now that the VPN tunnel connection is established between the client and the office, I want to view the office server using the VPN connection, so we need to set up static routing on the routers. I can now see the Office server for all my clients. However, we must keep in mind that routing is necessary and that the Office must respond to clients in order to prevent getting the packet dropped. Alright, let's check to see if Mike's computer can access the Johannesburg Office server from his computer. Let's turn off Mike's PPTP connection to show that we cannot see the server if PPTP is turned off, and then let's put it back on to receive a reply.